As you might remember from the demo earlier, separating compute and storage enables cost-effective scale for workloads. With the notion of turning down clusters, you may be worried about all the data that's currently stored on disk HDFS. You may be using HDFS on premises. What happens to that with our new Google Cloud Platform architecture? Your data is not stored in the cluster. Your data is now stored off cluster in Google Cloud Storage buckets. Really? Won't that make things slow to reach out across a network each time the cluster needs some data? Recall that earlier we mentioned Google's data center bandwidth between compute and storage. We talked about a petabit bisectional bandwidth. What that means is that if you draw a line somewhere in the network, the bisectional bandwidth is the rate of communication at which servers on one side of the line can communicate with servers on the other side. With enough bisectional bandwidth, any server can communicate with any other server at full network speeds. With petabit bisectional bandwidth, the communication is so fast that it no longer makes sense to transfer the files and store them locally. Instead, it makes sense to use the data from where it is stored. So here's a plan. We'll use HDFS, but we'll use HDFS only on the cluster for working storage during processing. But we'll store all actual input and output data on Google Cloud Storage. Because the input and output data is off the cluster can be created for a single job or type of workload and can be shut down when not in use. Changing your code that works on-prem to have it work with the data on cloud storage is easy. Just replace HDFS in your Spark or Pick code with GS. So you take the HDFS URLs, HDFS : and replace it with GS : //. This will make the Spark or Pick job read or write to cloud storage. That's it. There's also an HBase connector for Cloud Bigtable. So if you have your data in Bigtable, you can use the HBase connector. And there's a BigQuery connector that you can use to work with data if the data is in the analytics warehouse. So when we say off cluster storage, we're talking about cloud storage, or we're talking about BigQuery, or we're talking about Bigtable. So Cloud Data Proc and Google Cloud Storage are tightly coupled with other GCP products. So storing your data off cluster means that you can process this data not just with Spark from Dataproc, but also from all these other products. Not to mention, storing it off cluster in GCS is generally cheaper since A, disks attached to compute instances are expensive in and of themselves, and B, if your data are off cluster, you get to shut down the compute nodes when you're not using them. So bottom line, store your data in Google Cloud Storage. Friends don't let friends use HDFS. So let's recap what we've covered. You can get a Cloud Data Proc cluster up and running in about 90 seconds. This gives you all of the power of Hadoop without having to manage clusters. As you saw, you can lift and shift your existing Hadoop and Spark workloads by simply replacing HDFS : URLs with GS : URLs. You can connect Cloud Data Proc to Google Cloud Storage and unlock the benefits of both scale and cloud economics. You get to provision a cluster per job if you want to, and shut the cluster down when you're done. Lastly, your clusters are customizable, which could include auto-scaling and preemptible VMs so that you get cost savings.